The question says, a bob of a pendulum of mass 90 grams of length 5 meters is displaced through an angle of 15 degrees with the vertical shown below. So this is the diagram that's been given. This bob being suspended by the ceiling, and it is displaced by this angle from its rest position. Now the first question that we are told to find is, what's the gain in potential energy V? Show that the maximum speed is given by V is equal to 2gl, open brackets 1 minus cos theta. Then C, find the maximum speed of the bob. So this is the question that we're going to consider. Without even wasting much time, let us discuss. So whenever we are looking at questions or problems of this kind, it's important that we come up with freeboard diagrams. So here we can draw this. Okay, we have this, and this is theta, and then we have the mass here, and this one directly downwards, this is mg, and if we extend this is going to be theta by using z property or alternate angles. So this one, we have got this as tension. Okay, tension in the rope or in the string, and then this is mg, and again we have, so this one, the side that is adjacent, or the side that is adjacent to the angle is cos. So here we are going to have t cos theta. Then the side that is opposite to the angle, which is this side, and it is equivalent to this. This is t sine theta, just from SOHCAHTOA, to say sine is equal to opposite over hypotenuse and cos is equal to adjacent over hypotenuse. So this is the one. Now, in finding the first, okay, so let us come up with the answer for the first part. Finding the gain in potential energy. Remember that when the bob is swinging, when it is swinging, it has here, it has potential energy, which is simply 0 at its rest position. When it comes at this, it is having maximum potential energy. When it begins coming, it is kinetic energy. So in order for us to find the potential energy, it is just the aspect of relating potential energy and kinetic energy. Because energy can neither be created nor destroyed, but can only be converted from one form to another. So potential energy is equal to kinetic energy. And we know that kinetic energy is given by half mv squared. So let us call this as equation 1, or let us keep this equation just like this. Now let us resolve some forces here. We know that when the forces are balanced, then their summations must be equal to 0. So in the y-axis must be equal to 0. So we have the t cos 30, or t cos theta minus this one, the downward force, which is mg. This must give us 0. So we have t cos theta is equal to mg. Let us call this as asterisk 1. So from this, we can come to x, summation of forces in x. Okay, so here we have this t sine theta, and as it is coming, as it is swinging, it is going to be making something like a circle, or in a circular shape or circular path, and the force that is going to be produced by an acceleration that will be as a result of the movement of a bob in a circular path will be centripetal of acceleration. And so this sine theta and the centripetal force will balance. So we are going to have t sine theta must be equal to the centripetal force, which is mv squared over r. So we can call this as asterisk 2. Okay, so if we divide this, or if we divide asterisk 1 into asterisk 2, so asterisk 1 into asterisk 2, we have t, then here we just have mg. So this and this will go, and from trig ratios, sine theta over cos theta. So this is tan theta, which will give us, so we have this and this will cancel. We are going to have v squared over rg. So v squared is equal to rg tan theta. But the radius here, we do not have radius. So, but from this, okay, as it is coming in this direction, so the radius will be this one. Okay, this is theta. This is L. Okay. So using SOHCAHTOA, we know that sine theta is equal to the side that is opposite is r over hypotenuse, which is L. So r will be equal to L sine theta. So from this, we can plug in this. We are going to have expression. We are going to have L sine theta g times tan theta. So we are going to have Lg sine theta tan theta. So if you plug this or this expression into this, we are going to have half m. Okay, then we have v squared, which is simply this. So we can just replace by this. We have L g sine theta tan theta. If we wanted, we would have just figured it out from this point and finish everything from there. So here we're going to put in the values. We have half times the mass that we have is 90 grams, which is 0.09 kg, times length, which is 5 meters, times 9.8 sine 15 tan 15 degrees. So this one, what we are going to get when we punch on a calculator, we are going to get the value for potential energy. We are going to have 0.1458, which can be rounded off to 0.15 joules. So this is the value for the gain in terms of kinetic or potential energy. So now we are going to find or to show that the maximum speed is given by this. So let me just try to come up with a free body diagram one more time. So we have got this, then we have got this. So this is here, then we have got this one here, and then we have this point to this point. So this is h, which is the displacement from the original position or the point of equilibrium. Then we have this as theta, and then we have this one as L. Okay, so if then this one, let us call this as X. Okay, so this H and H here is, it is equal. So a combination, so from this point to this point and this point to this point, it is L. So this is the length of the pendulum, which is L, which is the summation of H plus X is equal to L. So our H will be equal to L minus X. But from SOHCAHTOA, we are told to say this one, X, it is the side that is adjacent to the angle. And from SOHCAHTOA, cos theta will be equal to X over L, which is adjacent over hypotenuse. And when we make it the subject, we are going to have X is equal to L cos theta. So this one, when we plug it in this equation, we are going to have H is equal to L minus X. So L minus L cos theta. So since L is common, we can even factor it out by saying L 1 minus cos theta. So this one, now we know that from energy conservation principle, we know that total kinetic energy must be equal to potential energy. And as the bob swings, the gain or the loss in kinetic energy must be equal to the gain in potential energy. So from this point, what we're going to have is we have half mv squared is equal to, this is the formula for kinetic energy, and for potential energy it is mgh. And since m is common, we can cancel m, we can cancel m here. And what we're going to have is v squared over 2 is equal to gh. From this point, we are going to have this one, so we can cross multiply to have just v squared is equal to 2gh. Now, if we put this here, where we replace this by h, so this is h. So we're going to have 2g, then our h is L, 2g L, 1 minus cos theta. And this one, if we introduce the square root, so we have got this one. If we introduce the square root to both sides, we are going to have this, and this will go, and what we're going to have is v is equal to the square root of 2gl 1 minus cos theta. So this is the value of the maximum speed of the bob as required here. And finally, so this is B. And finally, find the maximum